We live? We live? Hey, yeah, I should be live now, I think. All right, happy Friday everybody. Welcome to the Cool Stuff live stream. I am your host Aaron Patterson, also known as Tender Love. I like to start my streams on time, which is why I'm a prompt engineer. So, yes, prompt engineer today. Um Hello and welcome. We're going to do so as usual, we're just going to start off with some slides, talk about stuff, do some hacking, and then go about our day, I guess. Today we're gonna do. I have a very special guest on. Let's do the slides. Let's just do the slides. Where is my keynote? Keynote view. There we go. Yes, happy Friday, everybody. We're gonna hack on Vernier today, which is a new profiler written by John Hawthorn. I've helped a little bit on it, but it is all. I'm gonna blame him for all the bugs. um, we're gonna hack on Vernier today with John Hawthorne. We're gonna talk about profiling a little bit, and then yes, John. Oh no, talk about profiling for a bit. Maybe profile some stuff. We'll see. Depends on how much time we have. So, yes. So happy Friday, everyone. Last month, not last month, last time we hacked on Prism. I took last month off because I had gum graft surgery, and I wanted to do some healing, so I decided to take last month off so I don't sound weird while I'm on the live stream. So last time we chatted about Prism. This month we're going to talk about profiling. We're going to just profile stuff. So we're going to talk about specifically Vernier. As I said, this is a new profiler written by John Hawthorne, and today we're going to add a new feature to it, which is we're going to add allocation profiling to Vernier. Future topic idea: Rust in the YJIT compiler. That's great. That's great. Yes. Also, if anybody has ideas for future topics, please let me know. Happy to take suggestions and do them. So Rust in the YJIT compiler might be a fun one. I don't think I've done any hacking on the Rust version of YJIT. I can't remember. Well, I've done hacking on it, but I'm not sure if I've done it on the YJIT or on the live stream. So maybe next time. Uh, anyway, we're not going to go too far into, I'm not going to dive into exactly how profilers work specifically, because I had John on in a previous live stream and we did that. So if you want to know more about how sampling profilers work, I've put a link to that live stream in the description, but it's also here too. I don't think you can click on the video, but that is a QR code. Anyway, it's in the description, so if you want to check that out, go for it. Vernier is actually made of, this boy. We're gonna suffer through my webcam today. It seems to shut off and then come back on today. I don't know why. So I'm gonna disappear and reappear once in a while, I guess. We're just gonna live with it. Anyway, Vernier is made of two parts. Not really made of two parts, but there are two parts to using Vernier. First off, there's the collector, which is the Vernier gem. So you use this collector to actually get statistics about, oh, hello, Wayne. Yes, magic. You use the collector to get statistics about your application or the thing that you're profiling, but those statistics aren't super helpful unless you can read them. And we have a second part, which is the viewer. It's the profile viewer gem. It's the thing that actually takes those statistics and shows it to you in a browser. So kind of the relationship looks a little bit like this. Vernier will sample your application, get information about it, and then it outputs a JSON file. And then in order to make sense of that JSON file, we use the profile viewer gem. So the profile viewer gem will take that JSON file and turn it into a web page for you to actually check out, look at the stuff. What's cool though is the profile viewer gem is actually just a fork of the Firefox profiler. So I can't remember the website for it. I think it's profiler.firefox.com. But they have a website that they use for profiling Firefox itself, and you just upload a JSON file to their website. Yes, or you can now use vernier.prof. You can upload the JSON to that website and then basically look at all the same statistics. But what we did is we basically took Firefox's profiler, forked it, and then renamed everything from JavaScript to Ruby. Because of course, like when you're profiling Firefox, there's a lot of time spent in JavaScript, but we don't do that in our Ruby apps really. Wayne is asking, is it a snapshot in time or can you step through time? It is. You can step through time with this profiler, so you can go around, like when you profile for the whole amount of time, it'll show you that in the browser, and you can like zoom in on particular time, like particular times during that profile if you want to. Anyway, it outputs JSON, and I want to take a look a little bit at the JSON format today because that's what we're going to be messing with. We want to collect object allocation information and provide that to the Firefox profiler. And in order to do that, we have to output the right JSON. So our JSON file looks kind of like this. Basically, it's just got like a bunch of metadata at the top. We can specify like what the time units are, like whether it's in milliseconds or whatever. We can also specify like how many, I don't remember what else is in here. So just some metadata. It also has like these different categories. So you can categorize frames within your profile, which we'll kind of see. Oh, great, it disappeared again. Cool. Next in the JSON profile, it shows it like an array of threads, and those are all the threads running in your in your application as we're profiling. This sample one, so this JSON that we're looking at is JSON that I hand edited because we were trying to figure out like what does the JSON format look like? How do we convert a Ruby profile into something that the Firefox profiler would like? So I made a tiny little JSON file. And that I linked to that in the description. So if you want to like go check out that JSON file as I'm walking through it here, you feel free. Anyway, there's a list of threads. The threads point at the frames that like different call frames that have happened. They also point at a function table, and all of these together form basically a tree data structure. So you can think of kind of all the calls in your application as a tree data structure where the root of that tree is like the main stack frame. So we form this tree. Then later on we take samples. So if you scroll down, you'll see we have like a list of samples. The list of samples are associated with a particular time in which we took that sample. And then a little bit lower, hopefully I did this correctly. Yeah, a little bit lower we have the stack. And these are our samples. So this number here in the stack list, that's pointing back to an entry in that tree data structure. So it helps us keep the profiles really compact. Yes, this is absolutely artisanal handcrafted JSON for sure. So if we take a look at this, if you open this with Profile Viewer, it'll look something like this. You can kind of see like those are our stack frames. So if you grab that JSON file and you grab the Profile Viewer gem, you can open this JSON file with it and like mess around with the JSON and see how it impacts the Profile Viewer. But you can also see on the right-hand side, we've got categories. So those are the different categories that I had defined in that JSON file. All right, so what we want to do is we want to add, in this live stream today, what we want to do is we want to add allocation information. If you have allocation information, it shows like a new drop-down thingy in the website. And if you click that drop-down thingy, it lets you choose between timings and Ruby allocations. So we can say like, hey, I care about like time, or I care about Ruby allocations, which is what we want to add today. So the JSON for the Ruby allocations looks something like this. We just have to specify like when there was an allocation, what the allocation was, like the class type. We can also specify like how heavy the allocations were. So this is in kilobytes. I just put in some sample data here saying like, oh, we allocated 100 kilobytes or 200, 300. And then we can specify like where those allocations happened, and these numbers are just basically indexes back into that tree. So very similar to what we did for actually like profiling stuff, very similar to the time profiles, but this is just for allocations. So the way that we'll track these allocations, like we have to figure out how are we going to track Ruby allocations. One thing I was thinking is we could use gc.stat and say like, okay, every time we make a sample, we could say like how many allocations have happened since the last sample, kind of do it that way. So here's like kind of an idea. Like this code here lets you count allocations. So you can say like, hey, how many allocations have happened total? So the GC will keep track of like how many allocations have happened total in your application. You can say like how many happened total, and then subtract it from the last time, and then you know how many allocations happened between each of these. Now, unfortunately, like if we compare this data to the JSON format, this doesn't really tell us like what got allocated. Hey, happy Friday. This doesn't tell us what got allocated, and it doesn't tell us like how big the objects were. So maybe we can use this later, but today I wanna include like what it was and how big it was. It also doesn't tell us where either, so we don't know where those allocations happened, who to blame them on. Let's see. So what we're going to do today is we're going to use trace points for tracking allocations, and you may have used trace points in Ruby like this. Like, for example, if we want to track C calls, we can do something like this. So if you run this code, you'll see it output every time we call itself. So we're saying, hey, I want to know every time somebody made a C call. So this trace point will do it. But actually, there's more trace points in Ruby than are exposed in Ruby. There's a C API, and you can trace other stuff using the C API, and that's what we're going to use. There's actually a C API for tracing object allocation. So we can say like, hey, every time an object is allocated, I want you to call this callback, and it will, and then we can get information about the object that was allocated. So our general plan is we're going to register an allocation callback. We're going to record the stack trace for that. Then we're going to output those traces in a profile JSON, and then hopefully view them in Firefox, the Firefox profiler. So I am going to bring on John now, and we'll chat for a little bit and then get to hacking. Where is it? Oh, there we are. Hi, John.
Hello.
How are you?
Doing all right.
You I didn't share your. Did I share your title with you? You are a pontoon plane passenger, right?
I suppose so. I did take a float plane this morning. It
Ah,
was very nice.
nice. Are you a professional pontoon plane passenger?
I suppose that this maybe. I very much don't get paid to do it. Quite the opposite, in fact.
Is that what defines professional though? I mean, you're good at it, right?
Yeah,
You're good at your job.
I suppose so.
So, John,
I do think getting paid is what makes you a professional.
oh, okay. All right. Well, that's interesting. So, I got a question for you. So
Hmm.
Vernier already has some like allocation info in it, right? Like it's got a
Sort
profiler.
of. Yeah. So I originally didn't write it as a like time profiler. I originally wrote it as a retained memory profiler,
What does that
which
mean?
is sort of a so originally I wanted to figure out what like when after you boot your application, what's using memory.
Okay.
As in I wanted to know which things didn't get freed by the end of your boot. So that's the original purpose of it. But then we ended up making it a time profiler because that's generally more useful. But and we still have that retained memory tracing, but we have not implemented the second question, which is which allocations are you making in a request? Because like
I
that
see.
slows it takes time to make allocations, and that's going to make you run GC more, and that's often a thing we want to track and measure.
Yeah. Okay. That's really interesting. I don't think any profilers have provided like yeah, retained memory before. Wayne is asking, have you considered using dtrace in combination with Vernier for more information system wide? Any thoughts on dtrace? We have not tried combining this with dtrace, but I feel like you could. We provide dtrace hooks for allocation tracing, so I think you could do it. You'd basically just have to make a dtrace to JSON thingy.
Mhm. We're
But
we're a like in process profiler. The profiler runs in the same process. I think dtrace uh we tend to want to use for like externally tapping in.
yes, and I'm not sure. So like, I worked on the dtrace. Actually, I implemented the dtrace hooks, and one thing is like I couldn't figure out how to get Ruby level stack traces out of dtrace. Like we could easily get C stack traces out of dtrace, but we couldn't get Ruby level ones. So like, I
Mhm.
mean, it's got to be possible because I know they do it for JavaScript, but I think you need to know from dtrace. You need to know the like the format of the call frames and stuff so that you can like decode it. And I
Mhm. There's a eBPF profiler out there that's probably pretty close to that. It uses the same technique RB Spy has, where it has a uh, it knows internally what the Ruby structures are for a stack and stuff. Um, that
yeah,
profiler is cool. Lot there. We have many profilers, and that's a good thing.
yes, yes, I agree. All right, so but I don't think any of them, none of the profilers have answered the question like before Vernier. None of the profilers have really answered the question like, what stuff am I allocating and then holding on to during the boot
Mm,
time process. So I think that's like a
mhm.
really interesting question. Like, folks should definitely check that out because it's like I'm guessing like what it's probably I18N translations. Probably got like a whole bunch of those in
Yes.
memory. Like,
Yeah.
so you could find like this is why. So you boot your Rails app. Your Rails app takes, I don't know, 500 600 megs or whatever, and you're like, why?
Why?
So you could answer the question with that. But yes, as you said, so today we want to get actually allocations like during your request. Where are you allocating stuff, and how bad is it? What are you allocating? So I guess we should work. Should we work on it? We should
Yeah.
do that. Okay, I'm gonna move Keynote out of the way here. Do, do, do,
Oh
do,
yeah.
do, do.
Also, the retained memory thing. I don't that format you showed where it has the JS allocations and it shows you the types and stuff.
Yeah.
I'm not using that, and we should be using that. So that's a future project.
Okay. All right. Let's share the screen here. Us and desktop. Okay. Here is actually let's. I guess we'll show this off a little bit. Here is the profiler from that sample JSON that I had. So like here's the I don't know the timing. You can switch between timing, so you can see like how long we're spending in particular stacks. And then if we switch to Ruby allocations, we can see like, oh, well, I guess the JSON's not that interesting because I said like all allocations are happening at the same place, so it's like not that interesting. Like we could do. Let's fix that. Where was it? Alloc? No.
It should
JS.
be JS allocations or something like that.
Oh, I'm editing the wrong file. There it is. So we could do like I don't know.
Change the stacks.
Let's change the stacks to like 1, 2, and 3, and then if we let's make a new terminal. Then if we open them, min.json. There. Now we'll see like we can see different samples here. Like, oh, we had 100 bytes allocated in 1, 202, 303, for example. Let's look at flame chart. Yeah, there we go. And we can see like, okay, 3 had a bunch. Yeah. There we go. Okay. All
Your
right.
camera's gone.
Oh, I disappeared. Great.
Yeah.
Hey, I'm back. All right. Let's see. So I guess let's just start hacking on this. I have like a little
Yeah.
bit. I have like a little bit started. Oh, by the way, folks, if you have questions while we're doing this, like feel free, put it in the chat, and we'll answer anything. So just let me know. All right, let's hack on it. I guess. Where should we go first? Vernier CC.
Yeah. What have you already added?
I will show you. Get diff. So Vernier is written in C++ for some reason.
Yeah, sorry.
John, why C++?
Um, Mostly I wanted. I think the real reason is that I wanted a hash table that was not the built-in ST hash from Ruby
SD,
because I
sure.
didn't want to. ST's like a little bit slow compared to some of the more modern hash tables, and uh, profilers are sort of complex, so C++ is helpful.
Hmm.
I also like C++, but
Oh, I was with you
yeah.
until then. uh, so actually that makes a lot of sense. And for folks that don't know, there's inside of Ruby there is a hash table, and we call it ST. So if you look at
Mhm.
st.c in Ruby, that is the hash table. So I've added so far I've just added a little silly thing which I forgot what to
Mhm.
do. Right here is I added a new trace point right here. Uh, this is the trace point. So this is the C API for creating a new trace point, and we care about new objects. So this is the name of the trace point. We say, hey, I want to know every time there is a new object enabled or a new object allocated, and then we just give it a callback, which is this function pointer. I'm not sure what this refers to itself. I suppose we just want to. It's a void pointer, I guess, like a context
Yeah,
thing.
probably.
All right.
It's probably like a void star data
Yeah,
kind of thing.
we're just passing ourselves like the C++ self into the callback. And then I know what the problem was. So like when we shut down the profiler, we do this. Just say like, hey, we want to disable the profile. I remember when I was hacking on this, I was like, why isn't this working? And I have now realized it's because I never enabled the trace point. You have to create, so when you're using trace
Ah,
points, you have to create them and then enable them and then disable them. And I missed the critical like enable step. Not gonna do much good unless it's enabled. So I guess let's do that. I was
yeah, we
gonna,
must be doing that elsewhere in here.
yeah, for sure. So the I'm guessing the retained allocator must use the same trace point, right?
Yeah, somewhere we're going to find a new obj trace point.
Okay. So let's see.
It because it works by listening to new and free
Oh
and
yes.
just deleting the records it has when it sees the free.
Let's see. What is this one? This is base collector. This is the one I added, I think. So we got another one here. This is yeah. So this is the retained collector. So the retained collector cares
Mm-hmm.
about new objects and about freeing objects. So it must. Oh, there we go. RB trace point
Yeah.
enable. Cool. So let's add that here.
Yeah.
All right. And then I have a test program. Let's use a test program. So we'll just like require Vernier, do time profiler, do this, and then do 100 allocations and see if it'll print something. Right now, I just have it
Yeah.
print like
It should say hi mom
yeah, it should
100
say hi
times.
mom. Yes, is that right? Yeah, there we go. Yeah, so it should just say like hi mom. Let's try that. Okay. C++. It's like C, but one better, I guess.
Yeah.
Let's see. Test.rb. Hey,
Right?
nice. All right. So we're getting this callback now, and then we say, I think I just cribbed this from your other one.
Yeah. That looks right.
It looks right, but we don't have. So this is getting the object. What the
Mhm.
heck is going on here? I don't think this is right.
Collector record no, because
Yeah,
that's well, this is not right either, because we aren't expecting a retained collector.
right.
So
What is this?
time collector?
Okay. Time collector, and we probably ought
Yeah.
to. Yeah. And one thing I should mention when you're doing, like, if you register a trace point for object allocations, it slows down object allocations.
Mhm.
So
Yeah,
I feel like we should let people opt into this, but I don't want to do that. Like, I don't want to do that right
yeah,
now. Let's just get it working, and then
yeah, absolutely.
okay. So we do time collector, and then I still don't think record is right.
No, I don't think record exists. So for the retained collector, I think it's just a public method on
On the
retained
retained
collector. So we
collector.
should
Okay.
probably make a like essentially the purpose of this, so this new object I is we need to make a bridge between the way Ruby wants to call us and the convenient way to be a C++ callee.
Yes.
So this is just doing a cast of the data Ruby's giving us, which it doesn't know what it is. It's like a user data type pointer. Um, and we're just trying to like pass that through into
Right.
into something that we're happier to receive.
So this data is referring to this, which is
Hmm.
yeah. Okay. Yep. Yes. Okay. Cool. So we should add a new method, which is record new obj, and in that we're just gonna record like
I would start by just like printing out Paimon
oh,
or
didn't we
something
do
like
that?
that.
Oh, okay. Yeah. Okay.
Yeah, but it's like yeah,
let's implement record new
it's
obj.
incrementally
Sure.
getting there.
So where do we do this? We want to do this just as a public method, like
Yeah, that should
here,
work.
like void. I don't know C++. Help me out here. Ah, there we go. Yes.
Yeah,
I guess I know C++
it's
enough.
C but with classes.
Thanks. Value obj C,
Mhm.
but with classes. It's a classy C. Oh, oops. Hi, mom. All right, so let's see. Like, hopefully we make it into this callback now.
Yeah.
Okay. Hey, we're in the callback. Great. So we want to get, what do we want to get? We want to get the class, I guess.
Oh yeah.
Maybe we should just start by
Our
recording the stack trace.
yeah. So the thing I'm less sure about, like getting the class could be interesting.
Yep.
I I'm less sure about where do we record this,
Yes.
and because if we need to record it by thread, which we probably do, that might be a little complicated.
Let me check. Let's check the JSON, but I think that is correct. I think we do need to record it
Hmm.
by thread. JSON allocations. This looks like it is. Yes, it is inside of a thread. So yeah, we do need
Mhm.
to do per thread, like per thread recording. I mean
Mhm.
that's good. Like folks probably you probably want to know like what threads are allocating what objects. So that makes sense.
Yeah.
Okay.
So we need to do that. Collecting the profile should be easy, but we'll have to do it.
Yep.
And
Let's start with
yeah,
the profile stack trace.
yeah. Let's start with that. If we look at,
Oh, can't we?
I feel like
Can't we steal from this right here? No.
that looks pretty good to me, honestly. So this is passed in a sample which already exists, but we could make a new one.
Okay.
And it also comes with a thread, so it knows which Ruby thread that is, or which Vernier Ruby thread it is.
And a category and a timestamp. Let's
Mhm.
find the caller of record sample and see what it does. That makes sense?
Yeah,
Okay.
I think it's going to be pretty scary.
Oh goodness, this is scary.
Yeah. But we don't need to do most of this. Like the time sampling is far more complicated because it is the time sampling runs outside of like the Ruby. It's its own thread. It's not a Ruby thread. So
Okay.
it has to like reach into the Ruby thread, get it to stop get the Ruby thread to tell it where it
Where it
is
is.
and then deal with other stuff. Whereas when an allocation happens, we actually know exactly where we are. We are in the thread doing the allocation, and we know we're running Ruby code, specifically the Ruby code which does allocations.
Yes, yes,
So it
exactly.
should be similar to this, but a little different.
Okay, so let's figure out. I think the first thing we should do is try to figure out what thread we're on.
Um, yeah.
Okay. And we do that by what?
Um, somewhere.
We're gonna loop over all the threads we know about? No, that doesn't
Yeah,
make
we should
sense.
copy this code.
Yeah?
We
Okay.
definitely want to do well. Sorry, this. Let's grab this. These 3 lines.
Okay. You drive.
Yeah. Definitely want this. I think there's a better way to do this locking, but that should be fine for today.
Yeah, we need that locking because the other thread could be like trying to sample at the time.
Yeah, we don't want to be recording this allocation and at the same time try to wake up our thread and record
Yeah.
ourselves again, just because we'll corrupt memory probably.
Wayne is asking, isn't there an RB thread current? And I think there is.
Yeah, I think we also use that.
Nice.
Like
So
we use that here.
could we just take out the lock, grab that thread, and
So that RB thread current is telling us the Ruby thread. The thread we want to point at is my representation of a thread.
yes, yes.
So we should, but we can say like value current thread is RB thread current. That is very helpful. Thank you.
Okay. Now what do we have to do? We gotta find the thread, right?
Yeah, now we want to find. We need to find the thread which matches this.
The Vernier thread. So Vernier keeps track of, like, it has its own representation of every thread in the system, so it can record information about each thread.
Mm-hmm.
Actually,
I think somewhere we must be doing this already.
gotta be.
Yeah, let me look at class thread. So class thread has a Ruby thread.
Oh, okay. So we could just do a comparison there, huh?
Yeah.
Thread.
Why do I use which? Yeah, I think this is what we want. I don't know why. I don't know what the difference is between this and just double checking.
Equals. Okay.
Yeah.
All right. Let's do that.
Yeah, I think originally it was more complicated. So there were some changes that had to land because of the MN thread.
Oh, right.
Additions happening.
Yeah. Okay. Oh, by the way, if our levels aren't good, please let me know and I'll fix it up. Let's add a hi mom in here. Make sure we got.
Yeah, maybe we can add. Should we add this, but then with like, I don't know if there's anything interesting we have yet to print.
I mean, we could get the address of the current thread, but really all we care is that we were able to find it.
Right. Okay. Yeah, let's try this.
Okay.
I think we have made enough changes that it might have broken.
It did. What's wrong? Cannot initialize parameter.
It looks like thread equal wasn't defined.
Oh.
Let's switch it to double equal.
Okay.
This is a like. So as much as C++ is like a more advanced C, it has some of the weird C-isms where you need to forward declare all your methods.
Oh goodness. Okay, so we were able to find the thread, and then so we're really able to find this thread, and I think we can break out of the loop at this point, right? No.
Should
we just
record it? Or like the question is, do we want to say like thread.record allocation?
I think we do.
New obj.
Yeah.
With the obj.
Yeah, I like that. Yes. I
Okay.
think that's good. And then the thread can keep track of like all the object allocation stacks, and then
Yeah.
I like that. Um, then we should break.
Yes.
Okay. I don't know where to do this. Should we see what the compiler says?
Yeah. It'll be in
Thread.
Yeah.
Great. Class thread. Okay, cool. And then we need a method. Should I just slap it right here? Which I forgot. I already forgot what the method name is. My memory is that short.
I think we called it record new obj.
Value obj. Okay, so we got it, and then what? We need to get the stack trace.
Yeah, let's do that next. So somewhere in here, other places we're going to do this. So we have markers which we record, but somewhere here we're going to do a. I think this is the thing we want. So I have this concept of a raw sample, which is just my normal sample class is the one where you're getting another thread to sample for you.
Yeah.
Raw sample is you're sampling on yourself.
Oh, okay.
And then we're going to need this translator.translate call. That's the thing that takes the thread, the stack trace that's returned from Ruby, and converts it into that single integer
okay.
we were looking at before.
Right. So we have to do that translation from the Ruby stack trace into that thing, or into the basically the Firefox. Calculate the tree and figure out the integer in the tree that we want. Makes sense.
Yeah, I don't remember what type it is, so let's hope it's int.
Give that a whirl.
Yeah.
Wait, we need a frame list?
We do need a frame list. I don't know where that is.
Okay.
Red table has a frame list. Let's, for now,
pass it in.
Mm-hmm. And in here, we'll have to pass in frame list and compiles.
Where do we get threads? Is that on? Oh, it must be on the instance.
Yeah. Thread. Okay, it's our thread table.
Got it.
Okay. And hopefully that's public. If it's not, we should just make it public. That's not a big problem. So that's saying, I made two mistakes. So first is we're already inside thread, so we don't need to call thread dot.
So no thread dot here.
Yeah. And then the second mistake is I made this addition to the wrong one. I made the change in the static class, gotcha. Not the instance class.
Gotcha. Yep. Okay. Hey.
Okay.
And it doesn't crash. That's good.
Yeah. Yeah.
Nice. Should we check out what,
Yeah, let's print it out. We're expecting it to be the same every time.
Right. Stack IDX. Okay. Should make these one command.
Pretty interesting.
Some of them are different.
I think that's probably correct, though.
I think it's correct.
The last two are different.
I'm guessing that's correct, because I'll bet it's I don't know, call caches or just.
It's probably allocations Vernier makes at the end of it, of its run.
That makes sense. Sure, that makes sense. Yeah. We got to allocate the profiler or the profile results, something.
Have to allocate the hash to return the response. Which maybe means maybe in the future maybe that just means we want to unregister the callback earlier or something, but we can worry about that another day.
Yeah, I think this is good. This is very good. Okay, so now we got to record that stack index somewhere.
Yeah, so we have how are we going to do that? So we have inside of this thread don't remember where we record them. I don't remember where we record the like regular uh list of stacks. I suppose I can look for that.
Hmm.
So we
Let's
record
see.
markers in here.
Well, we care. Okay, I guess like it needs to be from the JSON's perspective. It has to be on the thread. So I
Yeah.
assume we have it on the thread.
I don't always do things the same way the JSON does.
Oh, okay. Is it not
Oh, there it
sample
is.
list?
Sample list. Yeah,
Okay.
there we go. Oof.
But we want another one. So these samples, these are for time. These are time samples,
Yeah.
right? Like we probably want one that's like object
Object samples.
samples.
Or object samples.
What is a sample list though? Can we look at that? I don't
Sure.
Stacks, timestamps, threads, categories, weights. This is kind of similar, but not exactly what we want.
Okay. We don't have to do it the same.
Should we make another one that's like
yeah, object sample list.
class object sample list.
Yeah.
And then we do want stacks, we do want timestamps. Threads seems not necessary.
Probably not. I don't even know if I am using the threads.
Weights we do want. That's just going to be, maybe is weights the right name, because it's actually like the size of the allocation, right?
I'm also not sure about that one, because like at what point is the size of the allocation meaningful?
Yeah, I was curious about this too, because like, so when you think about it, we have, I mean, there's multiple, when you allocate a Ruby object, there's actually different slot sizes. So I was thinking we could report that, whether it's like a 40 byte or a 80 byte or whatever, like whatever width the slot size is. But like people might care. So for T class or T data objects, like we can't, I'm not sure if that makes sense. You know what I'm saying?
No. Yeah,
like, for folks on the live stream, T data objects are Ruby objects that wrap a C data structure, and you can ask that object like, hey, what is your size? How big are you? And it's supposed to calculate its own size. But the problem is when we get these, like at the time we allocate this object, it may not have that data structure backing the object. So we can't really ask it for its size, or even if we do ask it for its size, the size may not actually reflect the total amount of memory that it uses.
For the retained allocator, this was easy because I record the sizes at the end of the run.
Yeah.
Because that's when I care about them. But I also I think we should just report one for now.
Yeah, let's do that. I agree.
I'm just going to copy these because they look helpful. A dot size, we have a dot empty, and then we're going to need to implement record sample. You'll probably want time stack and int weight.
Yep, I think that's it. And we're going to need another list for the class name, but I think we just put like, I don't know, object in there for now.
We're going to need another list for the class name. Yeah, I don't know what we'll report there.
Let's just keep a list of, can we keep a list of strings?
We could. Sure, let's do that. Well, strings, it could be complicated because like what type of string? Is it a
C
like,
string? C string.
Okay, but it's a char star, and we know that's never going to be freed.
Let's just copy it. Mem copy it. Yes. Let's guarantee it's never going to be freed.
I'm not sure. I'm less sure about that.
Why? Why? What's wrong with that?
Can we do that later? Like, we don't need to do that during the stream.
Fine. Yes. Yes. Okay. I was gonna say we just
if we're just gonna report object, like we can
just do it in the...
not do that.
Yeah. Okay. Okay. Sure. Fine.
This looks okay to me.
Yeah.
And then for the other one, we also have, maybe we'll get to this later. I moved the like output writing into this write result.
Okay.
Um,
Okay.
so maybe let's copy this because it also is going to be the same. But instead of samples, call it object allocation samples. What do we want to call the? This is not in the Firefox output. This is we have an
Internal,
intermediate
yeah.
output that we then translate into the Firefox output.
Let's call it object or allocation samples. Sorry. Yeah.
Allocation samples.
Because I mean, that's what it is.
And then we're pushing in the stack. Hold on. Push in. Oh, this might be a little gross, but allocation samples, allocation weights, and allocation
The heck
timestamps.
is
Maybe we
this?
want to do this different.
What are you
Like
doing?
maybe we want to make. You know what? Actually, like this is definitely time. Let's make a hash of
Yes.
let's say like allocations is RB hash new,
yeah.
and then we can hash a set allocations into the result.
Yep.
And then
samples, nice.
There we go.
Yeah, that's
a little better.
Yes.
Because it's this like intermediate format that like only I consume, I've
It's just
somewhat done a
garbage.
bad job of it. Yeah.
I read there was like recently an article about what was it, like inefficiencies in development, like I don't know, doing application development, and the author of the article was like, if you ask any developer, nobody will ever say that they wrote bad code. And I'm like, what?
Yeah. I can't relate to that.
No. I only write bad code. What are you talking about? Okay. All right, back to this. So we got to add that sample. We got to put this. We've created this class, but we need to like use it, right?
Yeah.
So let's find sample list. And I got to stop joking around because we only have like 12 minutes left. So let's like do this.
Mm-hmm.
Okay, let's see. Allocation samples. Yeah?
Mm-hmm.
All right. And then we're going to have to find where we record the sample.
Down here?
Here? Yep, this is it. So we need to say what?
Allocation samples dot record sample.
And then
I'm
that
guessing.
takes, yep,
Stack index.
Time, the current time.
Oh yeah, current time. We'll figure that out in a
now.
second. And a weight, which we're guessing is 1.
1, yep.
How do I record the current time? I think I can just pass in timestamp now.
Yeah, like 14 up, basically.
Yeah.
Yeah. Okay. Let's see if
I doubt this compiles.
Oh, come on. Have some faith. Hey.
Oh. Great.
Should we try running it? Okay, it compiles, but does it run? It does run. Okay, awesome. So does this means we should be able to get that no, we gotta hook in the the thing.
So yeah, so here we're going to be calling write result.
Yep. Right there.
So here we just I think need object samples. Was it allocation samples?
Yeah, allocation samples. boy, I was like, oh yeah, we'll definitely like be able to do some allocation profiling on Mastodon.
Mhm. Another time. We can do it another time.
Another time, yes. Okay. Let's see. Ooh. Okay. Huh. Why is this?
Uh,
We in the right place?
there. Um, uh, but didn't love the. Oh, I. That's definitely the wrong place.
There? Build collector result?
Yeah, let's try
Yeah.
that.
It's got to be thread arrow samples. Yeah.
I
Oh.
think so. I have multiple collectors, and I tried adding this to the wrong one.
Oh, okay. Thread
Oh,
hash.
I've just wrong variable. Should just be hash.
Hash. Okay, so theoretically now, unknown.
Perfect. No, this is good.
Is
So this
that?
is now we're in the Firefox output, and it got a keyword we did
Don't
not yet
know.
know how to handle.
Let's do it. Let's go fix that. Oops, 170 actually. So this is going to be allocations. And then should we just print it out? I don't know. Like,
Yeah,
see what it
that's
looks
going to
like.
be a good start.
Hey, that looks good.
That looks pretty good.
Yeah, that looks good. But now we need to stick that into our JSON output, right?
Yeah. How do I do this? I think we just want to save it first. Yeah, we just want to save it, and then we'll sort it out in the data. So we want allocations is allocations. And then inside of data,
Oh, here we
where
go.
we have samples, we also need JS allocations.
Is that right?
That?
Let me check the thing. It is JS allocations, yes. JS allocations, and we got to figure out what this is.
Yeah, let's do allocations table. And then
Luke is saying, I don't know if you want the malloc size or something else, but isn't there malloc size in macOS? Yes, there is malloc size in macOS. Also, I think JMalloc will provide it, so we can figure that stuff out. I think we could do like really interesting stuff, tracking not just like Ruby allocations, but also like any malloc allocations as well.
Mm-hmm. Okay, so here we need to return the
stuff.
Right keys, yeah.
Let's go look. Time, class name. I'll just copy these.
Yeah, let's do that.
Let's see. So time is going to be what?
At allocations time. That might work.
Okay. And then class name, we're just going to do...
Here's what we should do.
Size.
We should do at
yep.
allocations
time.size?
Samples.size.
Yeah.
Then that will be... I've done this hack a bunch of times.
Like star, yep.
Yeah. Just to make it legit. And then type name will do the same. These all feel like we could put really helpful things in here. Like if we can get the class name.
Yeah.
That would be really nice.
Hold 1 second. Let me try for a sec. This needs to be... That can't be object. It has to be JS object.
Oh, really?
Yeah. Because I think we can differentiate. So I think we can differentiate between JS objects, in our case Ruby objects, and like malloc allocations with type.
Oh, interesting.
I don't know what they mean by in nursery.
I also don't, but I think that's like I think nursery is a like GC thing. I think that means it's a young
Young
object, not an
object?
old
Yeah, that's
object.
what I was wondering. Does this mean it's young? Aren't they all young when you allocate them? Like,
I bet this is wrong, but uh, can we print this out?
yeah, sure.
Okay, how does that? How well does that work?
Poorly. Because we're
Just missing a comma.
Where are we missing it? Here.
There. Stack nil. I think I named something wrong.
Stack nil.
Samples. That should be samples, not stack.
That looks good.
Huh? Can we profile viewer it?
Yeah. Yeah. Let's do this again. Let's just like I take a look at the
open the file.
Yeah. JS allocations time is null.
Time looks wrong. That's probably supposed to be timestamp. Probably should have used fetch or something, but
I'm looking for JS. Time is still null.
Time's still null.
Wait, let me.
Oh, there we go.
There is it there now?
No, it's still null.
Okay. Oops. What are we doing wrong here?
Timestamps, maybe? Yeah, allocation.keys.
Yeah, okay. Probably should use fetch.
Timestamps, and we need weights also.
TS?
TS.
Yeah. Okay. That's looking good. Should we open this and see what's up?
Yeah.
Call tree empty. That doesn't seem good.
Yeah, it doesn't seem quite right.
And we don't have our normal time profiler and time profiles in here.
Oh, really?
Yeah, that's not good. Let's pipe this through. Oh, weird. Look at the samples. Like our stack is empty and time is empty.
The stack samples being empty is probably not unusual. There's probably not like you only made 100 allocations, so there's probably not enough stuff in there.
So what's happening? I'm guessing what's happening is that our intervals are too long. Like we have to have time intervals and allocation intervals.
Do you want to add just like a sleep 1 at the end?
Yeah, let's do that. Like here?
Yeah.
Is that gonna be good enough though?
That way, I don't know. We'll at least get some data.
Okay. There's timings, nice. Hey, there we go.
Great.
Right.
Did we do it?
We did, but the problem is those stacks. So those stacks that we're sampling from, okay. We're not seeing the right numbers here, and it's because we don't have stack recordings, like sample recordings for those stacks. So like, shit. Oh, I guess this is live. I can curse. Like our sample time when we're sampling, we don't get a sample in here, right?
We don't get a time sample, but we should get an object sample.
We do get an object sample, but the object sample or the I don't think we're not making that tree data structure for the object samples in time. So I think if we do like a sleep, let's say we do a sleep 0.2 here, for example, we'll get it. Let's
that's a long time though. Yeah.
Let's do like that.
Okay.
Sure. things. Ruby allocations, samples. Oh, maybe
That looks
actually
kind
that
of
is
correct.
right. Yeah, that looks good.
Mhm.
Yeah, nice. Okay.
Awesome.
Okay, so I think we're at time now, but we actually got this. We actually got this working. This is awesome. This is great.
Mhm.
So, the next things we need to wrap this up. The next things we need to do are we need to make sure that we have like we need to make sure that the overall like sample tree has stuff in it for our object allocation, so that stuff lines up correctly. What else do we need to do?
We probably need
Class
to make a
name.
way to class name. We need a way to enable, disable this, or maybe configure a sample rate.
Yes, because this is gonna very much slow down your app.
Mhm.
You don't want to do this all the time. So yeah, okay. But I think we made really good progress. That's awesome.
Hmm.
Okay, so let's stop here. Thank you. I'm gonna put you back on here. Say thank you so much for coming on. This was super fun. I had a great time hacking on Vernier.
Yeah, me too. Thanks for having me.
Yeah, of course. I'll send this to you. I'll send the diffs to you, and we'll like I don't know figure out the rest of the stuff.
Mhm.
Um, Chip is saying we should just leave the sleep in there. Yeah, I agree. Or just slow you down. It's fine. All right, I'm gonna go back to the slides here for a minute and then wrap this up. Okay, slides and keynote with me. Okay, that is it, everybody. Thank you all for coming to this month's live stream. I had a really great time. I'm glad you all came. I will do another one next month. I think May 19th or something like that. I'll put it in the like I'll schedule it in YouTube and we'll do it. If you have any suggestions for stuff that you'd like to see, please let me know. Super happy to present about really anything. I don't know exactly what I'm going to do next month, so if you have ideas, let me know and I'll present stuff about it. But thanks a lot. Have a great weekend, everybody. Next month, April. Is it April? Yes. Sorry. April. I don't know my dates correctly. All right, bye. I'm going to go now.